for for 11th standard. Now we are move on to the unit 2, algorithmic problem solving, chapter 6, specification and abstraction. Here onwards we are going to discuss about the algorithmic concepts, and that we mean it before we are going to start the programming skills. We need to have some clarity about algorithmic concepts because of the programming solve comes from the algorithmic strategies or algorithmic techniques. First of all, what is called algorithm? That means just a step-by-step procedure to solve the problem. If we have a problem, we need to solve the problem. We are write the steps. If suppose mathematical problems means we are starting the try to solve the problem from first step to nth step, we are finish the problem. So step by step we are going to solve the problem. So step by step procedure to solve the problem. This is called algorithm. And a number of process, that means step by step execution of sequence instructions. Sequentially we are giving instructions. They are giving an example that like a column in front of our house, we are putting the column inside the, and each and every point will be mentioned, and then they will be try to connect it in a some procedural manner that will be fulfill the task. And after that, cooking dish. If suppose preparing the rice, that means we have some of this step-by-step procedure. Like that, a problem will be solved by the step-by-step procedure that is called algorithms. Sequence of instructions to accomplish task or solve a problem. It is when the instructions are executed, a process evolves which accomplishes the intended task or solved. Suppose we are cooking something like biryani means. We have some ingredients. First of all, take all the ingredients and needed materials. After that, step by step we are giving into the pan and some other and water and rice and mixed of the some other chicken or mutton or like. So we are step by step added the ingredients of the mixture of the needed materials, and then finally the dish will be ready. This is the step by step procedure to execute each and every instructions. And G. Pauli was a Hungarian mathematician. He made a fundamental contributions to combinatorics, number of theories and numerical analysis. And G. Pauli was introduced in this algorithm concepts. He is an educator of the mathematics, and he was applying some methods to solve the problems in step-by-step manner, and it was something useful to him, and his problem was solved by the method of he is using. So, and he is understand the problem. How to solve the problem means, first of all, First step is understand the problem and devise the plan, carry out the plan, and review your work. These are the systematic steps to solve a problem. And finally, it's a algorithmic method. Normally, the definition of algorithm is step-by-step sequence of statements intended to solve the problem. Step-by-step procedure directly. And it may be the computational process, and we are trying to involve the inputs, and after the computational problem we can get the output of the given input, right? If you are An example is, if you are trying to add the numbers, add the two numbers means we have two inputs are there, and we try to add the numbers, and we have directly we have numbers or have some carry. If suppose 5 plus 2 means 7, we can directly put it here, put it there. And if 5 plus 6 means 11, so one is a sum bit, another one is carry bit. That is, that one will be go to the next step and added with the other numbers, other next step. So here they are given like that kind of a addition, and they will be trying to add the numbers, right? 6 plus 7, what is it called? 13. So 1 is carry and goes to the other step. 8 plus 3, what it is called? 11. 11 plus 1, 12. Second step. And another one is there. That is going to be other step. 5 plus 2, 7. And 1 is already is there as a carry, 8. And nothing is for transferred for the next step. So only 0. The fourth step is 9 plus 2, 11, 1. And another one is there as a carry that is given to the next step, and it's a fifth step. Already is there 2 plus 1, 3. Right? Like this is a sum bit and carry bit. Sum value and carry value. So like that, we already know this kind of steps, but it is also the algorithmic steps that the name we are missed out. Already we don't know about the algorithmics, right? And algorithmic problem, some of the principle and techniques for constructing algorithms, some of the critical problems, some of the crucial problems will going to be solved with the help of algorithms. Directly we are not going to be solved those kind of problems, right? And here one example is there, well known example. Already we say we know about this kind of this problem as a story, like story we are already known it, but it's an algorithmic problem. We have a goat and a grass and a wolf in one end of river. That a farmer will reach with all these things without damage to other end of the river. So how he is solve this problem? We already know this like a story, right? And first of all, what he is doing, farmer will gets the goat to the other side of river, and then comes get the grass and then go to the other side of the river and again gets the coat from the other side of the river and gets back to the this side of the river. And the next step is coat is which one is the left side of the river, that means first side of the river is released on that side and taking wolf to the other side and comes again and gets the coat to the other side of the river. So now not a single step we are going to solve this problem directly. We can't directly solve this problem. We have some chain link and some repetitive process is there and critical problem solving is there. So like that we can solve this problem with the help of algorithmic. This technique. The farmer follows a technique. That technique is called algorithms, right? And like that they are giving another example also is there, Cameron's and Cromlin problem, and also we are known that. And building blocks of algorithms. First of all, building blocks of algorithm. Next step is, what are the building blocks of algorithm? Building blocks means what are the important things we have to use on the algorithm and we can use, and these are the very important things we have in algorithm. Means first one is data, another one is variable, another one is control flow, another one is function. Data means we are using coat, grass, with the help of previous example. Coat, grass, wolf, farmer. They are the data, right? Right? That data we are going to store on the name of. Coat is the value, the person, that storage place, that place here. It's the two sides of river. Those are called variables. We are keeping that in that place, right? Just like a memory inside the system, right? That is called variables. Under control flow, what flow we are maintain to the value transfer. That means one side of the flow, he is going and coming and going and coming, like it's a control flow, right? And function, what kind of function, what kind of technique he is handled to solve that problem. He is doing something, gets a code and goes to the other and keep it that place, and again these are the functions he is doing, right? He is done. And data, we are algorithms take input. Yes, for this purpose we are using this data, taking input and giving output to the system. For that purpose we are using this data. For example, there are instructions for doing algorithmic operations or numbers: add, subtract, multiply and divide, and these are the functions. And for the purpose we are using the numbers or values, those are called data. And variables, that numbers, if we are directly, we can't give the 10 is into the system. That 10 will be go inside the memory. For that purpose we are allocating a space in memory. We are allocating a space in a memory, and on that space we are given a name for that space, because of we need to access that place with the help of that name. That name is called variable. That space is memory. We are putting the name for that space, that is called variable. That name, that space will keeps this data, right? This is called variables, right? And computational purpose, 10, a equal to 10. That a is memory space name. The a is variable. And then traffic signal may have An example, the flow, red light, yellow light, and which light is going to be next, that is flow. And red and blue, these are called variables, right? And control flow, we already said that, what direction, what flow, right? If we are cooking means we are maintaining a flow, right? We are preparing a tea means we are taking a cup of water and taking the tea powder or coffee powder and then mix it up, and we are maintaining a flow. If suppose we are maintaining that particular flow means we can solve the problem in correct manner, or otherwise we have some mistakes, right? And this is called a control flow. And sequential control flow, a sequence of statements are executed one after another, like same order. And alternative means we have some alternative. Suppose this or that. We have two alternatives means, suppose we have two alternative means any one of the things will be executed or another one is skipped. It's an alternative based. And iterative based means repeatedly one flow will be repeatedly doing. When the biryani is ready, before that we are doing with some process, right? And then functions is called functionality. Add is one of the functionality, subtract is one of the functionality. Doing something on the variable, stored, the data is there inside the variable, we are doing some functionality on the data, that is called functions. Maybe it's add, subtract, or doing some formulas. Those are the things called functions. The parts of algorithms are known as functions. Yeah, it's definitely. Suppose we want to calculate the surface area, like A equal to pi r square plus 2 pi r h means we need to solve with the help of functions, right?